I'm going to be talking about how we can automate the creation and delivery of software. And I'll be walking through a presentation, and afterwards we can do a little Q&A. But hopefully this is as exciting for you as it will be for me. In just a second, I will share my screen and begin. As I said, the idea behind this talk is to talk about opportunities for automating software development. And I want to just lay very clearly the purpose of the talk and how you should feel at the end of it. So the first thing I want to do is I want to motivate the feasibility of automating significant aspects of the creation and delivery of software in a very specific context that I'll make clear. I want to also show a plausible path towards attaining that. And finally, if I'm successful, hopefully I get you excited for the future. So the big question that I'm trying to answer here is it possible to automate software development? If you think about software is what we use to automate other industries. And as software gets more and more embedded in all these other industries, we hear a lot of talk and a lot of conversation about what's going to happen to jobs in the future. Here I'm asking, how about software itself? How about the creation and delivery of software itself? How does automation affect that industry? Is it possible even to automate the creation and delivery of software? So to motivate this even more, let's look at a thought experiment here. What if you could just speak to a machine and get software built, right? That's not what happens right now. It's a very difficult process to do this, but what if you could do that? For example, what if you could say, I need a ride every day at 7 p.m. when I'm done from work, and my groceries are stocked whenever I run out every Friday, and I'd like recommendations for cool events to go to. What if you could just say that to a machine and the machine was like, easy, sure, I'll just talk to the Uber API, I'll talk to the Postmates API, I'll talk to the Eventbrite API and just be done with your app. That'd be great. What if we tried a more complicated thing? What if we said, I need to build a marketplace that connects travelers with rooms put up by hosts, and the travelers can chat with hosts when they sign up and visit a listing. The listings are reserved between certain dates. Once travelers pay a deposit, the hosts add attractive images and descriptions to their listings, as well as instructions for how to get into the building. Payments are supported via credit card and Bitcoin. You can see here I have a funny image where the robot's like, huh? There's just no way to take this kind of description of software and turn that into an app today that I know of, at least. And so, the reason is gathering, understanding requirements and building software is really hard. Doing it very well, so doing it high quality is also very costly. The application that I described previously could easily cost $100,000 or more and take a few months or more to build. But where do we want to get to? We want to get to a place where you say that to a machine and it says, cool, looks like you want a travel marketplace similar to Airbnb with a couple twists and the ability to pay in Bitcoin. Done. That would be incredible. If we had that, then my mother could build software, right? She would just describe the software to a machine and it'll be done. So to go deeper a little bit into that example, how do things work right now? If you wanted to build something like that, what would you do? You'd probably go to a development service, you'd make a request for what you want to build. You'll have a bunch of humans kind of gather your requirements. So these could be salespeople, sales engineers, product managers. You'll discuss, you'll negotiate, and you finalize requirements, and you make a payment to get started. And then humans will put together a team of developers, designers, PMs, etc. And then work begins on your project. You get regular updates and builds to test, and then your app is done. It's not always that rosy though. So why would we want to automate? The process I just described seems awesome. Why wouldn't you just do that? Well, so you see a 2x2 here of what's affordable and what's high quality. And you see that it's really, really hard to get high quality software reliably at an affordable cost. If you get it affordably, it's usually very low quality. And if you get high quality, it's usually very expensive. And so the reason things are expensive for high quality is usually all the people and all the labor costs involved in building the product. And so that's why you should automate. If you automate, then you need less people to do something or less human labor to get the same task done. And so you can reduce costs. So how should we automate? The first thing I want to point out is if you remember the flow that I described, we actually have to think about the entire system outside of just software development. You know, you had a phase of capturing requirements. You had a phase of figuring out the price and the cost of something. And you know, for most software projects, you have a pretty long build cycle where you need to manage the project. And so you can't just think about the creation of the software itself. You have to think about the entire system, all the way from sales to down to project management, to development, to handoff, and to maintenance. And you know, you see a nice kind of timeline here for how projects typically evolve. So how should we automate? I want to call out that we shouldn't try to go build a general AI that can write code, at least not right now. That's not the path that I'm going to motivate here. I think that we should follow previously successful principles of automating things. And you know, one thing is to have a good process. And you know, Bill Gates once said that if you take an inefficient process and try to automate it, you're just going to amplify the inefficiency. If you take an efficient process and you automate that, then you amplify efficiency. So it's really important to have a good process. It's important to break down the work in that process into clear tasks, gather data on how humans do those tasks, and then use that data to build tools that automate those tasks. So what you end up getting is something like the Tesla autopilot, where you know, it's not that it's always driving for you, it's just that it can drive sometimes for you. So here, just similarly in software, it's not that the software is always writing itself. It's just that in certain cases where it's learned patterns, it can actually do those tasks and assist a human in the creation of software. So the big idea here is, just like with driving and just like with all the other areas where AI is making progress, we should first try to measure data, try to collect data on how humans are doing these processes and doing these tasks, and then try to augment the people through automation, versus sitting down and trying to write everything, you know, write an AI from scratch that can build software. So this is the path that I'm going to motivate in this talk. So like I said, the approach is that humans are a first-class citizen. Humans aren't a kind of second-class object that you're trying to get rid of. Humans assist in the process of automation. You have to collect data, so you collect structured data on the software development process. You want to collect data on the people doing the work. You want to collect data on the projects themselves that you're trying to build, and then you want to collect data on activity that's going on as the project is getting built. And I want to also point out that, unlike with driving or a lot of the other areas of work that are being automated, software is highly skilled labor. And so, you know, while that makes it more complicated, it also makes it more forgiving, because highly skilled labor is very expensive. And so even if you just automated a tiny sliver of the labor, the cost savings is still pretty high. So we gain a lot just from just a little automation, and it's okay to make lots of mistakes. The other thing that's important to keep in mind is, if you can incentivize people to be a part of this system, then you have a pretty big advantage. So, you know, how would you get all this data about work? How would you get all this data about activity? People aren't going to, on their own, just start submitting data about what work that they're doing. However, if it's actually just part of their job, or if they get paid more because they do this, then, you know, that's a pretty big benefit. So as we'll see later, this is sort of the approach that Gigster takes to this problem. It's basically, you have a marketplace of people, a network of people who get paid to build projects, and as they work on the projects, data is tracked about everything, all the way from pre-sales down to maintenance. And so, because people are paid to do various roles along the life cycle, you actually just get this data for free as exhaust from the work that they're doing. So incentives and taking advantage of the fact that you're dealing with highly skilled labor is really important. So it's always good to know how you measure progress. So, right, like, we have this plausible path that we've laid out. You know, we want to have a process, we want to break down the process into tasks. We want to know sort of who's responsible for those tasks, and collect data, and then try to build some systems that automate that. But so how do we know that we're making progress? What metrics should we use? So one metric that I really like is leverage. And leverage here is defined as the profit per worker. So imagine that there is a company or there is a system that's trying to kind of build all the world's software and is trying to do it in an increasingly automated way, then one thing that company could look at, or that organization could look at, is how much profit do I make on my projects, and how many people do I need to generate that profit? And if I need less people, then it means, if I need less people for $1 of profit, then it means that I'm getting more and more automated. And you can see an illustrative chart of this here, where for Facebook, this number is 1.3 million. And for Accenture, this number is something like $25,000. And so you can see sort of the difference there in how automated the service is. And so you could use that as a measure of progress. The other thing that you want to use is reliability. So if you have a high level of automation, there should be very low variance in project health metrics. So metrics like on time rate, customer satisfaction, are you on budget or off budget? Those things should be very, very low variance, and all the numbers there should be high in the positive direction. Okay, so we know the approach we're going to take. We know how we're going to measure progress. So what tasks should we start with? What things can we actually go and try to automate? And what are some kind of machine learning or AI techniques that we can use here, or even just common sense software engineering practices that we can use to make this process more automated? So I think the first thing I want to highlight is project definition, right? So the first thing we did when we came to this development service was we tried to explain what we wanted to build, and we tried to capture those requirements in a way that we could actually go forward with. So the problem here is how do you take unstructured natural language descriptions or detailed client specs of a project and people who are paid to actually capture these requirements, and how do you create a structured representation of the project? And by structured, I mean, you could see the example below. So for example, a sample unstructured description could be, I want my app to have accounts. People should be able to make payments. People should be able to search for items. And sort of the structured version of that, which is essentially like tagging that, could look like just accounts, payments, item search. And so sort of behind the scenes, every time we see these natural language descriptions pop up, even if they have slight variations, we can actually just pay the salesperson to record them in a standardized way. And we can build a UI, we can build a friendly tool that the salesperson can use to create these tags. And it's not additional work, this is work that they have to do anyways, right? To record the requirements, except we can ensure that they record those requirements in a standardized way. Now, when we sort of going forward, we can use past examples that have been labeled in this way to sort of reduce the involvement of these paid humans in the process over time, right? So next time when we see natural language descriptions of something, we already have labels for it. And so maybe we can use statistical techniques to figure out to infer what the tags are based on the natural language descriptions. And for things that we don't understand, we obviously can just use those salespeople to label them, and then the system gets smarter over time. The other task that we now have to do once we've recorded the requirements is how much is this going to cost, right? My mom wants to know how much that app is going to cost. This is a well-formed problem now, because now we have the structured representation of that project. If we have an understanding of resourcing and timelines, as well as this data for all previous projects that we've seen, including the costs and the timelines for those previous projects. Now we can form this as a prediction problem, and we can try to infer how much should a given project, given its structured representation and given the state of resourcing on the network, how much should this project cost us to fulfill, and how long should it take to deliver? Again, as you get more and more data on projects, you can kind of evolve your system. And typically this is done in a very human-intensive way in most services, and can be very prone to error. The next thing we should try to do is we should try to automate project architecture. So given sort of the structured representation of a project, as well as an understanding of resourcing timelines and the previous costs and timelines, what technologies should be used? What's the profile of resources that we should use on the project? What are the specific tasks that need to be done to accomplish the project, and the amount to pay for each task? So again, as long as we record things in a structured way, we can see a project and we can say, oh, this project is a marketplace type of project. And we typically are more successful when we use Node.js for these marketplaces, or typically takes 2 back-end developers and 1 front-end developer. And these are typically the tasks we see in this kind of project. And so over time, once we see enough of these projects, initially we have an architect who spells these things out, but over time we can replace that architect with simple templates and eventually with more statistical approaches. And then once we have these tasks, and once we have sort of this overall architecture, we still need to figure out, when should we get certain tasks done? Which tasks should we do in the first 2 weeks, and which ones should we do next? So here we need to understand what the dependencies between these tasks are. And the other thing we need to understand is what has been successful in the past for similar projects. And so again, here you can use you can use statistical techniques to figure out, for similar projects, these were the kinds of plans that we saw that worked in the past. These are the kinds of schedules that we saw that worked in the past. And you can recommend schedules of other schedules from other projects to be used. And you can also do, sort of very basic topological sorting type of algorithms to spell out sequences of tasks that need to be done based on dependencies. But again, here you can kind of minimize the variance that you get from just having different people come up with different ways of planning things. The next one that we can try to do is we can try to automate the sort of supervision and management of projects. So here you need a project manager typically to go over a team's work and say, have you pushed code? Have you finished your task on Jira or Trello? Have you emailed your teammate? And, is there regular communication going on stand-up? Now, because of the way, because of how programmable all the tools that we use are, all these tools have APIs, we can kind of interrogate them and understand what's going on and use software to help us out here. So with very simple algorithms and fancier algorithms, we can figure out, has there been code pushed to this repo in the past week? If there hasn't been enough code, there haven't been enough commits to this repo in the past week, what should we do about that? Is the sentiment in this Slack channel negative, trending negative, or trending positive? Is the sentiment in this email chain with clients trending positive or trending negative? And so because you have things like GitHub, Slack, Trello, email, Jira, and all these tools that have APIs that can dump data into some kind of central warehouse we can do analysis on, it's now possible for you to take the current state of a software project and basically predict the future of that project. Answer, is this project going to be on time? Will the customer be happy? Will the team be happy? Will the developer leave the team? Is the team getting along? And again, you have historical data, and you can sort of use that to motivate estimates for the future. Another problem that we can address is, given people who've applied to join this network to kind of contribute to building software here, who should we let in? Who's good? And maybe we can look at profiles of great developers that we've let in before, and we can kind of identify other great ones while minimizing bias. So team formation, this is also extremely critical. So given that we have the project, given that we have a pool of resources, given that we've structured the data on the project, we've estimated the cost and the timeline, we've actually put it into a schedule, who should we put on the project to actually build it out? How can we build kind of a recommendation system that can tell us what the best team for the project will be? And so here, if you've collected sort of what are the features on this project, what technologies are needed, and if you know information about the load on the network of developers, if you know information about the skill profiles of those developers, then you can basically frame this again as another prediction problem, where you're saying, if I were to select this group of people, what do I think the success outcomes on the project will be? What do I think the customer satisfaction will be? What do I think the on-time rate will be? And so on and so forth. What do I think the code quality would be? And you have this data. If you have this data tracked historically, then you can kind of improve your predictions on this problem. The other thing that you want to do is you want to come up with a rank on the developers, on the product managers, on the designers, and the testers. And you want this rank to kind of correlate with success on the project. You also want to make sure that you have enough people, you have enough capacity to actually address the software demand that's incoming. And typically in a lot of software development services, this is done manually. This is done through spreadsheets. This is done in kind of ad hoc ways. Again, we can frame this as a pretty formal way and say, given the active projects that we're working on, given the incoming pipeline of projects and all the structured metadata around it, given the available resourcing and the structured metadata around that, do we have enough people? How many people should we recruit? How many people should we reactivate while minimizing underutilization? That means we don't want to just let a whole bunch of people into the network and then not give them enough work to do. And then, sort of the final kind of set of tasks we can automate, which maybe is a little bit more ambitious, is coding itself. So if we have a structured representation of the project, how much of that project can we build automatically from reusable components? So this is saying, if I have a project that's accounts, payments, search, messaging, is it possible for me to build components that represent each of those things and have a framework that allows those components to talk to each other so that we can actually automatically generate as much code as possible from a formal description of the project. The other thing we can try to do is we can try to help people, because if we understand kind of the modules in the code that you're working on, if we've tagged this and we sort of see you get stuck, then maybe we can suggest someone else in the network who's done similar projects, who's maybe authored some of the modules in the project that you're working on to help you out when you're stuck. And even more concretely, we can sort of do much more advanced autocomplete, right? We could say your end goal in whatever way is natural to you, whether that's English or however you sort of think about the task that you're trying to do, and we will recommend useful code snippets and assist you. So I'm showing on the right here an image from a system called CodeMend, which is work by Jin Rong and Steve O'Neill. It's basically a neural network based system that sort of jointly models language and code and does what I just said, basically assists you in completing tasks that you've specified in kind of a more natural way. The other thing that we can automate is code reviews. So for code reviews, if you collect code review scores given by humans, and if those scores are given along multiple dimensions, say elegance, say modularity, say code cleanliness, and you also get natural language sort of descriptions of these reviews, and you have this historically over a large number of projects, and you also obviously have whatever's open on GitHub, whatever's accessible and open source available to you. Then maybe you can also produce these reviews that we currently rely strictly on humans for. So how feasible is all of this? I just kind of want us to take all that in. So basically, we've broken down the process all the way from project definition down to development itself, and we've talked about how having structured data and having kind of historical examples can help us model all these problems and automate a large part of them. So how feasible is it? It's essentially like trying to build a Toyota for software. So have a baseline process that's based on humans and augmented by machines, continuously improve that through data, and then continuously automate away repetitive tasks and free up people to focus on higher leverage tasks that ultimately drive productivity. And again, the main pillars are structured and unstructured data on people, projects, and activity, and sort of a sustainable financial incentive that keeps that flywheel going, that keeps this data continuing to come through. And how is this going in practice? I've sort of laid it out very in a very kind of generic way, because the goal of this talk is to just kind of motivate the idea. But in practice, this is very aligned with Gigster's vision. So solving these problems is basically at the heart of where we are focused at Gigster. So what we do is like you see, the data is kind of the core of all of this work. Without the data, we can't do any of this. So we obsess over collecting all of the relevant structured and unstructured data to empower internal teams at Gigster and to power various tools that we use to drive efficiencies. And I'll show you some of this data that we collect to kind of give you a sense of how this is being used in practice. And to give you more context, the reason this is important for Gigster as a company is that the more data we get, the more patterns we can see, the better tools we can build. And the more reliable, the more efficient we get, the more customers we get. And that is a flywheel that drives this data network effect. And this would be basically the first software development service that has any kind of network effect to it because of this picture you see here. And I mentioned earlier that a lot of this data is coming from tools that are only recently available to software developers. And tools like Trello, GitHub, Slack, Twilio, Jira, and so on. So you can see how are we doing so far. First, I'm just going to show some high-level metrics of kind of the projects that go through Gigster. And what I'm showing here is kind of counterintuitive. For a software development service, you would expect that the quality and the error rates would get worse as you scale, as you get more and more projects. And so what you see here is that as the active projects have gone up over time, the customer satisfaction on our projects, so proxy for quality, has gone up as well, and the error rates have gone down. So we have very positive scaling characteristics here. And then I just want to highlight some of the project data that I talked about earlier. So we track this data at sort of multiple hierarchies. First, topmost hierarchy is basically what type of project is this? What kind of cluster does it fall into? And you see a few clusters here. So machine learning classification projects, data visualization projects, marketplaces, social networks, chatbots, voice interfaces. These give you sort of the first high level abstraction of what type of projects that we're seeing. And then you go even lower level to the features. So you see here this pie chart showing things like accounts, things like API integrations, things like email notifications, things like item detail pages. This could be, like a video page on YouTube when you click directly into it. And so we go and we make sure that our projects have these sorts of labels because then this allows us to solve problems downstream. For example, if we wanted to build out a team, and we wanted to find people who have been the most successful with push integrations or with API integrations, having this data allows us to do that better. The next thing I want to show is basically the sort of activity data that we track from Slack, Trello, GitHub, and email. So you can see over here is a tool called the ingester, and it's saying hi to me right now. You can see we've tracked over 22 million data points across all of these tools. And we can kind of come here and see a very high level of all the data that's being tracked across the system. And this data can then power downstream tools that help us answer various questions about our projects. The other system that I would talk about is Karma. And Karma, this basically has to do with team building and sort of figuring out people quality. The interesting thing about Karma is that it has multiple dimensions to it. So you can see this developer that I'm showing here. He has a Karma score of 1146, right? But we can ask, why does he have a Karma score of 1146? And we can see it's broken down into various dimensions like code quality, customer satisfaction. How well does he answer questions for people on the network? How fast is he? What's the quality of the work that he does? And we can sort of see where his strengths are along multiple dimensions. And this allows humans, allows tools, will allow humans and will allow tools to put teams together in a more scientific way. The other tool that I'll show is something called Lambda, which allows us to reuse code components across projects. So like I was saying in sort of the code generation section, if we know the components that sort of build up a project, then we can try to make a framework that allows us to generate a large portion of a project simply based on a formal specification of the project. So I want to end with a comment on kind of what's the impact of going down this direction. If Gigster or sort of anyone who is interested in this succeeds at automating a large part of software creation, what happens? Do we kill all the jobs? You know, do we kind of end the world? So I'll walk you through my thoughts here. So I think as programming has become high level, we've got higher and higher level. We've got more programmers and not less programmers. So you know, initially you had to kind of write an assembly, and you had to know about ones and zeros. And now you write in Python, which looks not too different from English. And so as that's happened, we've got more programmers. And the demand for software continues to increase and vastly outstrips the supply for it. So if we automate a lot of these repetitive tasks out of the process, we actually end up furthering this goal of making programming higher and higher level. So now all of a sudden I can come and I can say, I want an application that has accounts and that has profiles and that has messaging, and that's the way I'm programming, at least at the initial stage of the project. And so what this does is reduces the barrier to entry for new programmers. And overall, it's going to increase the number of programmers, not decrease it. It's just that your definition of what a programmer is might change. So there'll be people who are sort of putting these blocks together, and those people will be, there'll be a lot of new people who join that programmer class. And you sort of have the people who you typically consider a programmer now, who are working at a lower level in the stack, and they're building the underlying frameworks and sort of the building blocks that others are using. So on that note, I'd like to kind of stop and take any questions. I'm a co-founder, CTO at a company called Gigster. You can contact me at debo@gigster.com with any questions or suggestions for improvement. And if you'd like to work with us to build out these ideas and to do research or to work on production systems, feel free to drop me a line. I hope that I've convinced you, though, that the future is really bright. If we break down the software development process into very discrete, concrete tasks, if we accept humans as a way to actually assist our algorithms to get smarter, then I believe that we can make a really huge impact in the way software is created, and we can make a really huge impact in what it means to be a software engineer. Thanks so much. I will sign out, and yeah, thanks for having me. Cheers.